What if I told you that right now, there's a tiny but real chance that you could walk straight through your front door without opening it, and that this impossible phenomenon is actually happening billions of times per second inside your body? This is quantum tunneling, and it's one of those physics concepts that sounds like science fiction but is so fundamental to reality that without it, the sun wouldn't shine, your electronics wouldn't work, and you wouldn't exist. It reveals that the solid, predictable world we experience is built on a foundation of quantum weirdness that defies every intuition we have about how objects should behave. Here's the mind-bending reality. Particles can pass through barriers that classical physics says should be absolutely impenetrable. It's not that they go around or over the barrier. They literally appear on the other side without ever having been in the middle. Imagine you're playing pool and you hit the cue ball toward a wall. In our normal world, the ball bounces back. But in the quantum world, there's a small probability that the ball would just appear on the other side of the wall, as if the wall didn't exist. The ball doesn't break the wall, doesn't squeeze through cracks, it just tunnels through. This isn't a metaphor or approximation. Particles actually do this constantly. The math behind it is beautifully strange. In quantum mechanics, particles aren't little solid balls with definite positions. They're probability waves that spread out over space. When a wave encounters a barrier, most of it reflects back, but some of it can leak through to the other side. If you detect the particle on the far side of the barrier, congratulations, you've witnessed quantum tunneling. The probability decreases exponentially with the thickness and height of the barrier. For something as large as a person walking through a door, the probability is so astronomically small that it would happen maybe once in a time period much longer than the age of the universe. But for subatomic particles encountering atomic-scale barriers, it happens constantly. Want to see tunneling in action? Look at any LED light. The electricity flowing through it relies on electrons tunneling through energy barriers in the semiconductor material. Without quantum tunneling, modern electronics wouldn't exist. Your smartphone, your computer, even simple digital clocks depend on particles doing things that should be impossible. But here's where it gets really wild. The sun is powered by quantum tunneling. Nuclear fusion requires atomic nuclei to get close enough to stick together, but they're positively charged and repel each other with enormous force. At the sun's core temperature, nuclei don't have nearly enough energy to overcome this electrical repulsion. They should just bounce off each other forever. Except they don't, because sometimes they tunnel through the energy barrier instead of going over it. This allows fusion to happen at much lower temperatures than classical physics would predict. Without quantum tunneling, stars couldn't shine, and the universe would be cold and lifeless.